Welcome to the solution to the 2019 AP Statistics FRQ exam, question number 2. This problem is mostly writing, very little math in this problem at all. It's a question that deals with experimental design. So let's just jump right into it. So researchers are investigating the effectiveness of using a fungus to control the spread of insects that destroys trees. Interesting, so they're going to use a fungus to get rid of the insects. All right. The researchers will create 4 different concentrations of fungus mixtures, 0 milliliters, 1.25 milliliters, or it's milliliters per liter, sorry about that, 2.5 milliliters per liter, and 3.75 milliliters per liter. An equal number of the insects will be placed into 20 individual containers. The group of insects in each container will be sprayed with one of the 4 mixtures, and the researchers will record the number of insects that are still alive in each container 1 week after spraying. So this is their experiment. It's an experiment because they are not just simply observing, they are actually giving the different containers a specific treatment to see what happens, and they're trying to see how many number of insects die in each container. So part A wants us to simply identify the treatments, the experimental units, and the response variable. Now, the treatments are what you give out, what is actually being given to the different subjects. So that would be the 4 different concentrations of fungus mixture. Make sure you're very, very specific on that. 0 milliliters per deciliter, or per milliliters per liter, 1.25, 2.5, and 3.75 milliliters per liter. The experimental units are what person, place, thing, object actually gets the treatment. So here, a lot of people want to jump and say insects. Yes and no. The actual experimental units are the 20 containers. Each container is being sprayed. Now, in the container are insects, and we would assume that every container has the same amount of insects, same type of insects. That would only make sense. But the 20 individual containers of insects are what is actually getting those treatments. Those are the experimental units. The response variable is what is being measured at the end, and that is the number of insects that are still alive in each container after 1 week of spraying. So please be very specific with these 3 answers and use the words directly from the problem. No one's asking you to make up new things. Literally steal the words from the problem. So here are my 3 answers, nice and typed up. So the treatments are the sprays with the 4 different concentrations of the fungus, 0, 1.25, 2.5, and 3.75. The experimental units are the 20 containers, each containing the same number of insects. And the response variable is the number of insects that are still alive in each container after 1 week. Don't shortcut any of that because you want to be as specific as possible with each of these responses. And part B of this problem simply says, does the experiment have a control group? Explain your answers. So first, let's actually answer the question, does the experiment have a control group? Yes. The definition of a control group is a group that gets nothing to compare to. And because one of the treatments was 0 milliliters per liter of concentration, that would obviously contain no fungus. So that is acting as my control group. So the containers that end up getting sprayed with 0 milliliters per liter of concentration form the control group. So any container that ends up getting that concentration level will serve as the control group, because the control group is a group that gets nothing that you compare to for analysis. Because maybe you find out that the fungus makes things worse and having no fungus is actually better. But without the control group here, we would not know that. Now the final question says, describe how the treatments, the 4 different treatments, can be randomly assigned to the experimental units, the containers, so that each treatment has the same number of units. Now, there are 4 treatments, 20 containers. So it would make sense that I could have 5 containers at each of the treatments. So step 1 is labeling each container with the unique number 0, 1 through 20. I use 0 and 0, 1 instead of 1 just because some random number generators will not produce single-digit numbers as well as double-digit numbers. Now, most probably will, but anytime I'm using single and double-digit numbers, I like to play it safe and always use double-digit numbers. Just got to put a 0 in front of that 1. That's nice and simple. Then how am I going to generate my random numbers? I'm going to use a random number generator. You can also use a random number table to select the random numbers. Got to make sure that any repeats get ignored. If container number 5 comes up 2 times, well, it's already been picked. I can't give it 2 different concentrations. And numbers that no container has also get ignored. So if my random number generator picks 67, then, well, no container has number 67. Now, a lot of random number generators, you could specify a range, so telling it to only give you random numbers from 0, 1 to 20. That way 67 is impossible. But again, I always like to cover myself and say ignore repeats, ignore numbers that no container has, just to be safe. Now, here's where I got to be very specific on what happens, because a lot of kids will actually stop and just list number 1 and number 2, and they don't actually go into specifics, and that's actually what's required here. So the first 5 numbers selected from my random number generator will correspond to the 5 containers that receive the first concentration level of 0. The next 5 numbers selected, again, ignoring repeats, ignoring numbers that no container has, will correspond to the 5 containers that receive 1.25 milliliters per liter. The next 5 numbers selected will correspond to the 5 containers that receive 2.5 milliliters per liter. And the remaining 5, well, they actually have no choice because I've already picked 15 numbers. There's only 5 numbers left. So the remaining containers automatically get the 3.75 milliliters per liter. Now, it's really important that you list that last step there. You can't just say, oh, the first 5 numbers get this, the next 5 numbers get that. Well, make sure you specify first what they're getting, 0, 1.25. Now, you don't have to go in the same order that I went. You could have started off with 3.75. That doesn't matter. But it's really important that you say, hey, I'm going to pick these 5 random numbers. Those 5 random numbers correspond to 5 containers. It's the containers that get the level of concentration, regardless of whatever that is. Because I know this is silly, and a lot of kids will say, but it's common sense. But that's the whole point, is you got to explain this so that you don't have to worry about is it common sense or not. Because some kids will say, I'm going to pick 5 numbers, and those 5 numbers get the concentration. No, the numbers don't get the concentration. The containers corresponding to those numbers get the concentration of fungus added to them. So that's actually a really important detail a lot of people overlook. So in a question like this, it's very short. There's only 3 parts. There's no math, right? You don't even need your calculator. It's very simple. This is the type of question to really take your time to make sure that your answers are perfect, very well worded. Don't cut corners here because you think it's easy, because then the problem is you cut corners, you end up not getting full credit on a problem that was really easy and should give you full credit. So that's it for this question. It's a really easy one. Hopefully you enjoyed it and understood it.